To calculate the energy released in a nuclear reaction, there are two methods. Either they give you the masses of the nuclei of both the reactants and the products, and you find the difference in the masses. So the here the mass of the reactant will be more, and this will be less. That's why at that mass defect, this is the mass defect, is converted into energy. So this is the energy release. The other way is the binding. If they have given you the binding energy, in that case, what will happen? The binding energy of the products and the binding energy of the reactants will be different. So the binding energy, if they're giving you per nucleon, you can multiply this by the number of nucleons. So they give you the mass number, and then you can subtract this and you can get the energy. So by both the methods, by the binding energy method and the mass defect method, you can get the energy released. Depends on the data they have given. If they give you the binding energy per nucleon and give you the mass number, you can multiply both of them, get the binding energy of the products and binding energy of the reactants, and then you can subtract and get the energy. The important thing is that the binding energy of the products is more than the binding energy of the reactant. So this is more, this is again less. Now, why is the binding energy more? If you know the curve, if you go fission, you're moving here, so you are increasing the binding energy. One reason. The other reason is because the mass is less. Mass is less. So this mass is less, it has been converted into binding, so it becomes more stable. So it is something like